So let's take a look at a few examples where we find the union and intersection of sets. So the first example gives us set A with these 6 elements and set B with these 5 elements. So the first thing we want to do is find A intersect B. And A intersect B is the area of overlap. And when we look at these two sets, we want to see what elements are in both of the sets. So if we look in set B, you can see that there are only odd numbers from 1 to 9. And in set A, we've got numbers from 0 to 5. So we're looking for the odd numbers in this set, and this would include the number 1, so that element is in both sets, and also the number 3 is in both sets, and so is the number 5. But those are the only elements that are included in both sets, and so this is the intersection, the set containing the numbers 1, 3, and 5. Next, we want to find A union B. And the union of these sets means all of the elements that are included in the first set combined with all of the elements in the second set. And where there are repeats, we don't need to write them again. So the lowest number that's contained in either set is 0, so I will include that. And then we have the consecutive numbers 1 through 5. And those are all the elements of set A. But in addition, in set B, we have several unique numbers, so the numbers 1, 3, and 5 have been included already, but the numbers 7 and 9 have not yet been included. So we will include those in our set as well. And this set represents the union of sets A and B. Taking a look at example B, it asks us to solve this inequality and to express it in interval notation, but then also to write it as two statements using AND. So when we solve this inequality, we want to isolate the x, so we will subtract off the 3 from all 3 segments. So on the left we have -3 minus 3 gives us a -6. In the middle, our +3 and -3 cancel, so we just have 2x. And on the right hand side, so we've got less than or equal to, and 5 minus 3 is going to give us a +2. Finally, to isolate the x, we divide everything by 2. And we're going to end up with, on the left, -3 is less than x, which is less than or equal to 1. Okay. So this is our 3-part inequality, and we could write this in set notation. But it also tells us to write this as two statements using the word AND. So I'm going to look at the first portion of the inequality on the right-hand side and say that x is less than or equal to 1. But at the same time, while that number has to be less than or equal to 1, it also has to satisfy the other condition. And that condition is that -3 is less than x. But if I were to put the x on the left-hand side, I'm going to say that x is greater than -3. So this is our way of expressing this inequality by using two statements with an AND connecting them. Next, let's take a look at this problem. It says to graph and express in interval notation x is greater than 4 or x is less than 2. And to do this, I think I'd like to use a number line and to graph these two inequalities. So I have the important landmarks at 2 and 4. And for x greater than 4, I'm going to shade to the right. And because it's a strictly greater than and the endpoint is not included, I'll make this curved. So that's the first inequality. Now the second inequality is that x is less than 2, so less than goes in the direction towards -infinity. and the endpoint is curved because the point is not included. So this expresses the second inequality. Now, if this had been an and, we would be looking for the regions where both inequalities are satisfied and there is no region of overlap. So if this had been an and, I would have to say that this were a null or empty set. But because it's an or, we are actually going to include both of these intervals. However, there are two intervals, and so we have to write two pieces of interval notation. We're going to say that the first interval goes between negative infinity up to positive 2, with neither of the endpoints included. And then, because this is an or, I'm going to say union, so that it means include all the points in this first segment, but also include the points that go between positive 4 and positive infinity. So we have two intervals that we put together with a union to express that both of these are included, but we are not looking for the region of overlap, but we are looking to combine all of the points in the first interval with the points in the second interval. Now, one of the important things is that we are not allowed to put this interval together as one piece. So the interval above, we had expressed it as two pieces connected with the word and, but if we wanted to graph this on a number line, we would be looking at the number line and negative 3 is on the bottom and positive 1 is on the top. However, the region that's included between is a single region. It's one interval, not two. When we have two intervals, we should leave our expression as two intervals with the word or. If we try to put this together in one inequality, so it's tempting to say that x is greater than 4 and then also less than 2, but the problem with this is that 2, when we compare it to 4, is not greater than 4. So this is not correct in this inequality. And we can see that because the interval notation includes two regions on the number line, that we should not be able to put it together as a single piece in an inequality. To finish up with a couple examples, we've got an inequality that needs to be solved, so we'll divide both sides by 2, and we get x is greater than negative 2, and then the other inequality, or x is less than 0, we can leave it as is. And I think the easiest way to see what's happening here is to graph each of these inequalities. So we have the important landmarks at 0 and at negative 2. So for x to be greater than negative 2, we're going to shade to the right. And that endpoint is going to be curved because it's the point is not included. And then we've got x less than 0. So here's 0, and less than 0 means to shade to the left. So this is the inequality for the second expression. And what we're seeing here is two inequalities. One is greater than negative 2, one is less than 0, but when we look at the region where, when we combine these two sets, we see that we actually engulf the whole number line. And so the solution to this is all the points, going from negative infinity up to positive infinity, all real numbers. And the reason for that is if something is either greater than negative 2 or less than 0, this region of overlap, we include all those points, but we also include all of the points from the first inequality and also from the second inequality. If this had been an and, we would then have that region that's contained in the middle, the region between negative 2 and 0, but again, this does not say and, it does say or. For example, E, it says to graph it and express it in interval notation. So let's first do the graph. We've got at positive 4, x is greater than positive 4, so I will shade it to the right, and greater than, again, as a curved bracket. And x is also less than negative 3, so negative 3 is smaller, and less than means shade it to the left. And so when we look at these two intervals, and means that they both have to be true at the same time. This is the intersection. And as you can see in the shaded regions, there are no points in the left shaded region that overlap with the points in the right shaded region. So there is no overlapping. The intersection doesn't contain any points. And so in interval notation, we don't have an interval that's true. So we're just going to say that there is no solution. If you were to write this in set notation, we would make it a set without any elements, the empty set, or perhaps use the null set symbol.